Action. How's it
Hi,
going?
I'm Nigel Watling. I'm a technical evangelist for InfoCard.
Excellent.
Work in the developer platform evangelism group.
Yeah.
And with me is...
I'm Andy Harjanto. You forgot my name.
No, I was letting you
Okay.
introduce yourself.
Okay, I'm Andy Harjanto. I'm the program manager with the InfoCard team, right here building 4E, Microsoft. Okay, and I guess today we cannot talk about the InfoCard, right?
Yes.
Okay.
What is InfoCard?
What is InfoCard? What is InfoCard? I think the best way actually to look at the scenario, right? It's very simple scenario, end-to-end scenario of InfoCard. Okay, so if you can just project it to that. So we have actually the old demo here, because I couldn't get it to work with the new build. So I'm going to have very old demo. So this is day-to-day scenario. We have a site, let's call it Amazon.com. Right? And normally you can either have the username or password. Right? You can enter username and password, or you can probably use the InfoCard. So there's a new option over there that the site will be able to say, I want the InfoCard instead.
Okay.
Okay? So select the InfoCard. Okay. Just gonna pick one of the card. This is basically a self-issued card. Okay. Self-issued card is the card that actually I created myself. I have the other cards like a Visa card. That's a card actually issued by somebody else, by the third party, not by myself. Okay, makes sense so far?
Yep.
All right, I'm just going to submit it. And that's basically it, the user experience. There's no password, there's no username. Okay,
Interesting.
any question?
So that basically is replacing username and password, right? So what we're doing is we're replacing username and password with a card, which is kind of what we do in real life. So
Okay.
if we go to a, I don't know, in the US anyway, let's say, if you go to a liquor store here, you have, or even a bar, you have to prove your age, right?
Right.
It's not obvious to everybody that I'm over the age of 21, it seems, at least in this country.
Okay.
So
Well, you are 20.
I am over 21.
Okay.
So I present, say, my passport or my driving license or something like that. I don't give them a username and password, but I give them a card. So what we're trying to do here is extend that idea, that metaphor, the thing we use every day in real life. But we have a virtual set of cards, right? And when we go to a website or a service, we just pick a card and use that card rather than having to remember 1,000,001 usernames and passwords. Right?
Correct. Correct. So you can use the same card actually
Yeah.
going to a different site. So this is important. You don't have to have, a different card for a different site. That's basically, a lot of people confuse. Is this to have to, carry multiple cards? It means for each site? The answer is no. It's basically, you can have one card for multiple sites if you want to.
Sure.
So what's actually in the card then? When I present it to a site, what's in that card?
So this is actually a very interesting question. What's in the card? So we have the architecture, basically. There are three types here. We have what we call it identity provider. Okay. And this could be basically the issuer. You probably want to turn up the light over there
Yeah,
so
sure.
we can see it better. There we go.
Is that better?
Much better.
So this is the identity provider. So this is probably the issuer. This is who actually issue you the card, and who basically later on will issue you a token. This could be maybe a Visa, maybe could be a AAA, could be maybe Starboard Preferred Gas. I'm a member of Starboard Preferred Gas, so they can issue me the card.
This could be my government as well, right? So
This could be government.
This could be the US government, or maybe my college or my school that I go to. It can be basically anybody, right, who's willing to vouch for my identity.
Yep. And this could also be actually a different company, right? Imagine you basically, this is Microsoft. Maybe you want to have good relationship, working relationship with Intel, and this could be Microsoft issue you a card as like an employee card.
So this is a physical card or a virtual card that you're
It
talking
is a
about here?
virtual card. It's not a physical card. You're right. That's a good point to make here, to be made here.
Yeah.
All right. So this is identity provider. So, and the other interesting about the identity provider is could be your self-issued card. And this is a card that you created yourself. This is similar to, like, for example, the business card.
Right.
Okay.
But why would anyone trust a card issued by me? I understand if somebody issues, say Microsoft creates a card for me and says,
Right.
yeah, Nigel works for Microsoft, his employee number, rah, rah, rah.
Right.
He's worked at the company this long, he has this spending limit or whatever. That has some cachet, and it's from Microsoft or whatever. But if I issue it myself, I mean, who's going to trust me?
Right. So the self-issued card is normally like a low value card. You do not normally trust this card. Like today, if you go to Amazon or maybe Barnes Noble or somewhere, right? You registered with your, you type your name. You can do anything you want over there.
Yeah, it's true. I guess when you go to a website and you fill in the form, you're just presenting that information yourself. You're just typing in the information. You could be just completely lying in there if you wanted to, but you're creating an account at Amazon or you're creating an account at whatever website it is.
Correct.
So instead, you're just presenting a card instead of making up your information in a form. You're making up your information on a card and presenting the card.
And you can still use that card for authentication, right? Even it's self-issued, but probably they don't say, I'm not going to trust you that you are a gold member, for example.
Yeah.
Right. I just basically allows you to use this card. Next time you go to this site, if you use this card, then I'm just knowing this is you.
Can you tie your card into other authentication mechanisms, like Passport?
Can you tie the...
So if I go to Amazon.com and I already have a Passport account set up with them, can I just say, apply my InfoCard to this account?
Sure, there's multiple ways you can do. We can talk about it.
Sure.
The card itself has the authentication mechanism, and we can talk about it. How do we actually... There's another concept of an SDS, and we can talk about it. Let's focus on actually a simple case first, right?
Okay.
So that, and you have a client. Okay. So what normally happens is the identity provider, like these issuers, right? You already have a relationship with Visa, or AAA, or SPG, and this all government. Makes sense. So maybe the scenario here is you basically log into the identity provider like a Visa. You're a Visa member or AAA, right? You log on to AAA, and then the AAA will say, please download the card here. Okay, and the card is basically that CRD file. Okay, makes sense.
Yep.
And basically, what's in the card, right? And you can, this website say, please download your card, or can also, send this CRD file over the email or over some other mechanism. Doesn't matter. So what's in the CRD file is nothing more just a metadata information. There is no claim values. There's no real values in there, but it's mostly just telling what is the card name, the card image, for example. The more importantly, right, where to get the SDS. SDS is Security Token Service. We'll talk about it.
So that's where you get the data from. So this is just, all the card says is where to get the data from. There's no real interesting data in there. It's not my name in there, or my age, or my credit card number. None of that stuff is actually in the card itself. The card just says where to get that data from.
Yep. So you get the SDS, and that SDS will have, a list of, well, let's call it URL, even though the real thing is actually an EPR. But let's just call it the URL for now, for simplicity. And the list of URL will say, how do I authenticate to this SDS for me in order to get a token later on? Okay, so the authentication mechanism could be, Kerberos, or maybe using the X509 certificate or smart card, right? or the another URL maybe say I'll be able to do the self-issued card.
So I'm using a self-issued card to get a card that I've created myself to get another card from a provider such as Visa or the company that I work for or my government. So I'm using one card to get another card.
Yep.
And whereas my card has stuff that I've said about myself, the other card has more authentic information from somebody like a government who you're going to trust.
Yep.
But all I'm using that self-issued card for is basically to authenticate to the proper place to provide authenticated information. Yeah.
Right. So if you look at the card, the other important things in the card is basically the supporting claims. So supporting claim is basically a list of claims that this identity provider can provide you. Okay. Mm-hmm. Example is maybe I can, like in the case of government, I can say my supporting claim is maybe the date of birth, maybe. Right. If it's a AAA, for example, maybe the supporting claim will be membership level or something like that. Mm. Right. In the self-issued card, we have a list of fixed set of supporting claims, like a first name, last name, address, a city, and so on. This claims actually is pretty much extensible. So somebody, as long as the identity provider can say, I support the following claims, mm-hmm. and number of claims, and the relying party will, later on we'll talk about the relying party. Relying party will say, I require this XYZ, and if the identity provider support XYZ ABC, for example, then this card will be selected because it's a superset, basically, for what the relying party asks. Okay. So all this metadata, and the other interesting things about this is you have to sign the whole thing. It's signed by the identity provider.
Okay.
And in this signature, we'll have a certificate of the identity provider as well.
Excellent.
Okay. So you got the card, right? Mm-hmm. So InfoCard is, if you look at the UIs, right now it's a collection of a card. So the experience as follows. You got the CRD file from the identity provider. Say, okay, now I'm the user will be able to double click this card, the CRD file, mm-hmm. and then it will show basically a UI. Okay, and the UI, some UI here, and then it has the basically the issuer. Let's make it AAA for now, and maybe may have a logo. And the logo itself is actually part of the certificate. So the logo
it's embedded in the certificate.
Well, it's not really embedded in the certificate. There is a model that you can embed in the certificate. Mm-hmm. But one model is actually you put the URL of the logo mm-hmm. plus the hash of the logo.
So it can't be tampered with, right?
Correct. Yeah. So we match the hash. And also you have the issuer, and plus you have the logo. Okay. And it tells you like the supported claims, blah 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 blah, and basically the user is asked, "Are you sure you want to import this?" Right? The issuer of, I'm sorry, I have to verify this. This issuer is actually the issuer of the certificate. So, one normal say like maybe VeriSign, maybe, right? Sure. So the logo of VeriSign. So, and the user, once the user say yes, I like to, import this. This goes to becomes your collection of a card.
Right. So we know that it's a valid card, and we're not. There's not some bad guy trying to deceive us because we have a certificate that verifies the identity of the IP. So I know it really is my government. I know it's my company. I know it's whoever.
Yep.
And is this these images and is this what's called a high assurance certificate? What's that about?
Okay. So there are IE introduced IE 7.0 introduced high assurance certificates. So the high assurance certificates, basically there's a high degree of assurance. This is actually if you look at today, for example, just give you the problem right now. If you look at today in the trusted root CA, there are probably like 150 trusted CAs. And some of the CAs actually can issue the certificate for maybe like $40 or $50 without much more due diligence. So there's a programs in the high assurance certificate making sure that the certificate that the CA produces is really high value certificate.
So the consumer, if it's a high assurance certificate, the consumer or whoever can be really confident that it really is the right company and they're not being deceived, and that the certificate authority has actually done some checking and due diligence, and that the revocation list is bang up to date, and all those kinds of good things, right?
Yep.
Excellent.
So the other thing about the InfoCard actually supports the high assurance certificate. So if we detect it is a high assurance certificate, then what we do is we put some kind of a check mark, a green check mark, in front of the field. So for a given field, like for example, some CA may be capable of asserted that the organization name is really AAA.
Okay.
And some other high assurance certificate will say, really the location, there's some location here as well. The location of this company may be, somewhere, Seattle,
Yeah.
Washington, U.S. All right. So that's pretty much it. You put it in here. Okay. So now you have a collection of cards. Could be coming from AAA in this case, or Visa. This could be a self-issued card. Blah 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 blah. But each basically carries the metadata. So we have the information, the metadata here.
So I have a bunch of cards. Each of them has different claims about me.
Yep.
And then when I go to a website, for example, I can use the appropriate card for that website that has the claims that I need. Perhaps there's a website that, say, needs my age, or needs my postal address, or needs my credit card information. And then I just pick the right card for the right context.
Correct.
Yeah?
Correct. So what you're describing there is we have identity provider, we have clients. So there's another party, what we call it a relying party. And in our example, could be Amazon.com, could be other website, doesn't matter.
Netflix,
just
whatever.
Netflix. Yeah.
Always very unimaginative thinking of our
Yeah.
website names.
We keep
We
calling
should say live.com, shouldn't we?
we keep calling it fabricam.com.
Channel9.com.
There you go.
Exactly. So, what's the role of relying party here? Okay. So, what normally happens is when the clients try to connect to some protected resources, could be a web page, could be anything, could be just like a method, like a web service method, or anything, right? A protected page. Then the relying party can express the requirements, what we call it policy. It's an overloaded word, but let's call it for now policy. So if you look at policy, it's basically just the requirements, and the policy will say the requirements is, I want the issuer to be AAA because I'm going to give you a discount if you're a AAA member. And I want to have your, supporting claim. Your claim to be, maybe like a membership. I don't know, member number or something like that. Your first name, your last name could be, and maybe a token type. I forgot to mention this is in the CRD file. Also, you have a token type, supported token type. So token types. So if identity provider can provide more than one token types, they can specify in here, or one token type doesn't matter. So one example, they can say I can support token types. I can produce, for example, SAML 1.1. I can support any other token types. The InfoCard system doesn't care.
So we can have absolutely any token type at all.
Exactly.
if a security system has some really strange bespoke security token, doesn't matter. InfoCard will still provide that between an identity provider and a relying party, because InfoCard doesn't really care what that security token looks like, right?
Yep. Exactly. So this token type, again, this is actually optional. You don't have to say this token type. So let's call it SAML 1.1 for now. Issuer is also optional. If you don't care about the issuer, you normally do care about the issuer, but if you don't, you can say, I'm just going to say issuer to be null. What it means that I don't care about the issuer. I just, get me the token, I'm going to process
So
it.
that's a wild card. As long as you have the card that provides the claims that you need, you can get it from any identity provider, right?
Okay. Exactly, including self-issued card. Okay. So you get these requirements, and these requirements will flow to the client, the client app. And the client app could be, surprisingly, could be a browser. Surprise, surprise. It could be, just a fat client app as well. So what happened is InfoCard will take these requirements, okay, and match that with the cards. Okay, and only cards that can satisfy the requirements will be light up. So let's assume this actually satisfy this. These two cards satisfy the requirements. So this will be light up, and the rest will be just kind of gray out.
So you can only select the ones that meet the requirements. That makes
Correct.
sense.
Okay.
Great.
So the other thing, the user has to select between these two cards, which one he or she has to select. So let's see, he picked this card. I'm going to select this card. And then great, InfoCard system will take this card and read the metadata information. This metadata information is enough to connect to an SDS, basically a service that give you back a token. So SDS is basically, give me one token, I'll give you back another token. So exchanging the token. So let's assume that the URL is X5 certificate. So we'll take this one out. So and it goes to here. So the token to the we present it to the SDS. Let's see, this is the SDS. It's X509 cert. And we also present this policy requirement. So we include this policy requirement along with the request to the SDS.
Okay.
So the SDS will look at it and then say, yes, I know you. And yes, I can make the SAML 1.1 token, right? And the SDS will coming back to you with a token, with a SAML token. Of course, we care about all things like privacy. It has to be encrypted. The token will be signed. It has a proof possession as well. So everything is really secure in this case as well. So SAML token comes to the client, and the client basically say, okay, I get this token, and I'm going to bubble up to the client app. The client app, again, could be a browser. And the client app will just post the token to the relying party. Okay. The other thing that I forgot to mention is actually this relying party in the policy itself. We require the relying party to identify itself. So it must have a certificate in here. Of course, it has to prove that this site, it has the proof of possession of this certificate as well.
Okay.
So this certificate will flow to us. Okay. The certificate will be used two purposes in our case. One, if the user never seen the relying party before, okay, we're going to display what we call a trust dialog. This is similar to what we saw before when you import a card.
Yeah.
This is the same way. This certificate, we look at it. If it's a high assurance certificate, we also have the check mark. So it's actually the same dialog box, and the user has to make the conscious decision whether to continue with the communicating with the relying party or not.
I see. So it's exactly the same. So before it was saying, do you trust the identity provider? Do you want to trust this identity provider? And now we're saying, do you trust this website? Given the details about the certificate and whether it's a high assurance certificate.
Right.
Right. So is this certificate just an SSL cert on the website?
This could be SSL cert, right? And this SSL cert could also have a logo associated, same way, same thing, right?
So the logos will appear in the dialogue, and you can.
Correct.
Yeah.
And again, this actually could also be a high assurance certificate as well.
Cool.
Okay. So makes sense. So get here. So what we do is also this token will be encrypted. So that's the first purpose. The second one we talk about too. This token will be encrypted with this certificate. So we'll have a public key of that certificate will encrypt the token.
So end to end, it's encrypted. So nobody listening or sniffing the wire can actually see any of the information that's in the security token.
Correct.
And in fact, I guess if the token is encrypted using the relying party's certificate, the client itself can't see what's in that certificate, right? Because it's encrypted.
So there are two models actually. If the client gives the identity providers the relying party certificate, right? Then you're right. The client cannot see the token.
Right.
Okay. Because we don't parse the token. In fact, InfoCard doesn't want to parse the token.
Right.
We have a concept, what we call a display token, so that along with the token, okay, we'll have this. In this case, we'll have what we call it a display token, and this token is displayable in the UI.
So it's just to show the user what's in the actual proper security token, so the user can decide. Do I let this confidential information about me go to this website or not? Okay.
So that's one version. The second version is because of the privacy. Sometimes the user, right, does not want to reveal the relying party to the identity provider. So in this case, maybe like for Netflix, I said I don't want to reveal that to AAA. That I'm visiting Netflix.com.
So AAA is completely unaware of the fact that I'm using my AAA identity to authenticate to Netflix. Exactly. They just don't know about it.
Exactly.
Well, I guess it's the same as if I'm going to the liquor store. The department, the department of the licensing doesn't know that I'm using my driving license to prove my age. It's the same thing.
Exactly.
Cool. Which brings up the question about classes of InfoCards. So. I might want to use the same class of card for Amazon, Netflix, Pottery Barn. I wouldn't want to have a card for each one.
Right.
I might want to have one card I use for each, neither of them knowing that I'm visiting the other using this card.
Yep.
That's excellent.
So that, and then you presented the token, and because this relying party has a private key of this, so it can decrypt the token. Okay. And open up the token, crack open the token, and we'll be able to look at the claim, right? Maybe the claim in this case, in this example, is the member level, and first name and last name, right? And then the relying party can make the authorization decision based on the issuer who issued the token, and also based on the claim. Right, the claim value in this, then make some authorization decision based on that.
Okay, so let me see if I've got this right. So users can get cards from identity providers, which can be a company or your government or your credit card, your bank or whatever. That gets to you as a CRD, and you import that, and then these cards appear in the InfoCard UI when you want to use them. In order to import them, you have to go through some kind of trust dialogue saying, do you trust this particular issuer? And if you do, then you import them. Once you have those cards, and you can also create your own cards, in which case I guess you're the trusted person. Then if you want to use a card, you go to a website that supports InfoCard, and then in the policy of that website it says, we need these claims and from these identity providers. So goes across, and the cards that meet that set of requirements, those claims, those identity providers, those are the ones that light up.
Yep.
I select the one I want to. It might be more than one.
Yep.
And then when I select that card, what happens is details in the card say where to get a token that contains all that information.
Exactly.
But in order to get that information from the identity provider, I have to prove that it's me
Yep.
to the identity provider. Otherwise, if I could just grab them without proving who I am, it's not secure, right? So I have to authenticate myself to the identity provider in some way, which is Kerberos or X509 or a self-issued card.
Smart card.
Or a smart card. You can use
The
hard.
same thing, yes,
You can use a smart card as well, like a device. So I prove who I am to the STS. The STS says, "Yeah, I know you're Nigel. Here's the security token." I might not be able to see that security token, but I have a display token that tells me exactly the information that's being revealed. So yeah, I'm happy with that information going to this website. When I say yes, the token goes across to the website. Website cracks open the token, can see who the token came from, and the claims in that token, and then authenticate me, authorize me, and let me do whatever I'm supposed to be doing on that website.
Yep, exactly. That's the flow. That's basically the overall
Great.
flow.
Cool.
Exactly.
So we have someone new has came into the room.
Introduce yourself.
Arun.
Hi, I'm Arun Nanda. I'm the architect for InfoCard,
Aha.
and I'm glad I caught the tail end of this presentation, which these two guys are doing a wonderful job. So
Sure.
maybe I was learning a little bit too in terms of articulating it.
Excellent. So you're one of the brains behind the creation of InfoCard, the implementation and design.
Yes.
Fantastic.
Yeah, Arun is the big brain behind InfoCard. He's the guy that wrote. If you want to find out more about InfoCard, then there's some documents on the web, which they're beta 2 at the moment, I think. But there's like guide to integrating with InfoCard and the InfoCard technical reference, I think they're called.
Right.
And Arun authored those, so those are really good sources to find out about InfoCard. And there's probably a couple of other people we should mention as well, like Kim Cameron,
Yep.
who everybody knows, he's famous.
Yeah.
Famous
He was on
Canadian.
Channel 9 before.
He's been on Channel 9 before, and he's created the larger umbrella of the identity meta system, of which InfoCard is really our concrete realization. That's our specific implementation on Windows. And we are hopefully creating a very compelling user experience which embraces all the concepts of the identity meta system that should win over not only just the end users, but hopefully the model is going to win over a trust ecosystem of identity providers and relying parties as well.
Fantastic.
Because it's going to become so easy for users to select an identity in a given context, which is privacy honoring, which means it actually protects their privacy. And second, it embraces the notion of identity independent of a specific token types, specific technology, specific identity provider, and so forth. So it's an inclusive architecture which makes it very compelling.
And it basically eliminates phishing in the following sense, because if I go to a site that claims to be somebody else
Right.
and they have the UI that looks like that and the username password dialog box, it's just not going to work, because they're going to get information that they won't be able to understand. Further, you're going to tell me on the client side that they don't have a valid certificate. Don't trust these people.
That's right. Actually, one of the big underpinnings of the InfoCard experience is what we have been referring to as mutual authentication. Up to this point on the internet, the relying parties who demand an identity of me have been in the driver's seat, because they will insist on accepting my identity under their own terms, using their own experience they would like to project to me. And what we are saying is that, hey, that's not sufficient going forward, and that's the reason why phishing is on the rise. And so we are creating a paradigm and an experience, or a ceremony, if you want to call it that, where the user is saying, no, that's not enough. I want to know who you are in a trusted manner with sufficiently comprehensible, sufficient security characteristics and the ease of use, so that I can determine on my own whether I want to release my information to you and interact with you or not.
Fantastic.
So we're putting the user in control. That's the basic idea, right? The user is in control of their identity and their privacy and everything else. It's probably worth. We haven't talked much about where InfoCard sits in the identity meta system, I guess. InfoCard sits on runs on Windows. It's supported by Vista, and it ships as part of WinFX. So that means it will run on XP and Windows Server 2003. As far as browsers are concerned, it runs on IE7, and if you want to play with the samples, look at Andy's website, for example, and try the IE stuff. It works with the IE7 Beta 2 preview, which I think became available like 3 or 4 weeks ago, and with the forthcoming February CTP for WinFX, you can download that. When you install WinFX on a machine, it installs InfoCard, and you can go into the control panel and you'll see this little CPL saying digital identities. You can double click on that and start adding cards.
So with the IE7 dependency, is it running as a WinForm hosted in IE? Why the IE7 dependency or requirement?
As opposed to why can it not work down level?
Sure. Or why can it work in another browser that can support?
There is nothing. InfoCard has been specifically designed so it can be. It's absolutely a design requirement that it can be supported by any kind of software that runs on Windows. And indeed, we expect other vendors to produce versions of InfoCard on Linux, on Macintosh, or I don't know, Atari, whatever you want to have it. There's nothing. It's all using these WS Star specifications, which are completely open. Anybody can use them. As you've seen, that the InfoCard system itself is security token agnostic. So it just needs to sit on some client machine, on some client operating system, and it's just like the conduit for this flow of security tokens.
Yeah.
So,
I mean, it was just Nigel made an excellent point of describing why it's an implementation detail in Windows.
Well, yeah,
implemented it.
Sure.
It's
I mean,
not
the whole point is it's the internet, right? Which is, from some point of view, perhaps it's unfortunate that it's not just Windows. But it's basically, there's a whole bunch of different machines out there. There's people with different identity systems. And the whole idea of the identity meta system that Kim has thought about and discussed in the open is that it supports all of this existing infrastructure and these existing identity systems. And the fantastic thing about InfoCard, at least from my perspective, is that it is completely it's platform agnostic. We have built a stack, and it's part of WCF. So the way you access InfoCard is through WCF on Windows.
Windows Communication Foundation.
Yeah, Windows Communication Foundation. But it can. There's nothing to stop it being. Well, it's not only nothing to stop it. We want it to be on Windows. We want it to be on Macintosh. If it's only a Windows solution, it's not really good enough. It has to be everywhere, and we're here and we're listening and we're working with people you probably wouldn't expect us to work with to try and get this thing to work, because the internet misses this identity layer, and it's clearly a problem. Like the people getting phished and lots of security problems, and we're trying to address that. It's it's not just Microsoft's self-interest; it's in everybody's interest to solve these problems, and then once we get this behind us, then we can go back to competing really hard.
Excellent. I mean, it's one of the hardest problems to solve. As simple as I want to know that the email that I just got is from you. That's an incredibly complex problem to solve today. In fact, it's impossible.
As simple as it sounds, it is an incredibly complex problem.
And you solved that with InfoCard.
That's one of the problem domains. One of the problem domains we'd like to go solve as well.
Fantastic. So we've covered the architecture, right? To some degree here. We've covered the flow. We haven't covered how it works.
Yeah, we've covered the relying parties, the identity providers, where InfoCard sits. We haven't talked about the architecture of InfoCard itself and how it sits in Windows and the different DLLs and how that works. But
actually, it's more interesting just to look at the programmatic access, right?
That's true.
How do we do program in InfoCard?
Yeah, the program build.
Probably it's more interesting now.
Well,
you probably
definitely
want to turn off the light over there. Front. Yeah. See. So what I have here is the very simplest. Can you see that? Okay, cool. So this is the simplest WSCF application, right? So I have a client, and we can also talk about the browser later on. So what I have here is the service, and the simplest service you can find, and the simplest client you can find. And I show there just how easy you are to migrate from the username and password if your service actually asking for username and password and migrate it to InfoCard. Okay. So what I did here, just going to go line by line quickly here. I have a service, and the service I'm highlighting here, the service will basically saying, I'm going to start my service, and the security binding that I like to use is InfoCard. Okay, and I have the same client on the same project. Normally you have two different projects, but right now, just for simplicity, make it one project. And the client will open up the channel, and they will create the channel to talk to the service and just say hello world. So this is a hello world application. So what I like to show is the app.config. How do we do this? I just look at the binding here quickly. Let's see. This is what it takes to do. Very simple, straightforward. So in the binding, in the server side, the binding say my client credential types equal the issue token. So if you have February CTP, we rename it to issue token instead of InfoCard. And if you want more complex, a little bit more complex model, where you can specify the token type, I'm just going to highlight this, and you can specify the set of claims, then you can do that as well using the WS Federation HTTP binding. Okay.
Okay.
And you can also specify the issuer. In this case, I want to be a self-issued. We talked about it. You can specify the other issuer as well, but in this case, it's self-issued card. And that's pretty much it. So I'm gonna just run this program, walk through one by line, see. Okay, compiling. I'm just gonna take the simple binding for now. And come on, we're listening. Should be listening now for now. Oh, I have a wireless problem here. Okay, that could take a while. Just waking up. It should be very, very fast normally. Let's see. Okay, now I'll take the client with simple binding. And I'm just going to say go. And that's actually the client will look at it and says, now I need to present the kind of like what we call it InfoCard token.
Mm-hmm.
And the client will basically start the InfoCard. And the InfoCard UI should pop up in a few moments here. I still have a problem with wireless here. Should pop up any second.
This is Murphy's Law on display.
Yeah.
Yep.
And we can run it again. in second.
InfoCard doesn't
Should be
solve Murphy's Law.
It doesn't solve Murphy's Law.
Murphy's problem.
Something is. There we go. Finally. Sorry about that.
No problem. This is
So,
real time.
This is a collection of a card. I have Alice. I have another, managed card. This is my game card, Xbox card. That I'm just going to send it.
But they grade out because they don't meet the policy of the relying party, right?
Yep.
Okay.
There's only one card that's suitable.
Yep.
The Alice Woodward card.
Yes,
Now, is that a self-created card?
Yes, it is a self-created card.
Oh, you timed out. We need to run it again.
So I need to do it right again. I got timed out. Just
Sorry, I shouldn't have said something there.
okay. The reason is only a self-issued card because in the app.config, if you remember, I asked for self-issued card only. If I remove it, it will be different.
I still think the self-issued card construct is a little vague, at least in my understanding right now.
Mm-hmm.
So is that the card I would use to say that I'm me? Now, and how does that how is that proved? I mean, we talked about it briefly, about how...
Well, when you go to a website like Amazon, how do you prove to Amazon that you're you when you're creating a new account with them?
Okay.
You just type in a form, right? And you just say, I'm Charles or whatever, and this is my address.
Mm-hmm.
You are asserting that information. It's the same. It's exactly the same. I mean, in this case, you're doing it with a card rather than typing in a form on a website.
Okay, but I guess I meant this in terms of like who's issuing me the certificate. How do I create my own card? How's that for a question? that make more sense?
You click on you go into Control Panel. You go to see that Digital Identities control panel at play. Double click on it. You get into the InfoCard system. You click Add Card, and away you go. You type in the fields, and then you've created the card.
So is your confusion that when I present a self-issued card-based token to somebody like Amazon, how do they? There are two questions really. How do they know that it's me who's saying that? And I think the more important thing from their perspective is how do they know it's the same guy on a repeat visit when I go back there? I'm the same guy who presented the first time. So let's tackle those two things separately. The first one about how do they know that I am who I say I am is what Nigel was responding to, which is they don't really care as much. I mean, what really matters to them is that when I go and I create myself an account, which means I really submit some personal information to them, that's a way for them to hang some profile information about me. And they want some predictability that every time I come back, they kind of know who I am. They want some predictability around that. But there's a security aspect of it, that is, when I go back the second time, I must prove that I was the same guy who was there the last time. And that's done in the background, which normally today is done through passwords, right? I create an account. Every time I go back, if I can present the same password, then they know it must be the same guy. It must be Arun who came back because he happens to know the secret, right? InfoCard takes that burden away, and it has got some cryptographic characteristics which kind of happen under the hood without the user doing anything. So they actually generate the equivalent of strong passwords, and they cryptographically prove that. So the act of a user presenting a card underneath not only presents personal information, it also presents this key information and proves itself to the site. And that's all happening through the protocols, essentially. The user doesn't really get to deal with the secrets and the key material anymore.
So it's not just these claims that are going over the wire in the security token. There's also some cryptographic information that uniquely identifies the user to the site.
And proves the user to the site. That's important. It identifies and proves that the user is truly in possession of that key.
Fantastic.
So that's really if you heard the RSA keynote that Bill Gates made, and he was talking about, the era is near where we would like to move away from passwords and start employing stronger secrets or stronger keys. This is really one manifestation of that, is that users, by their very nature, because they are generated by human beings and they have to be remembered, they're weak. And by removing passwords as key material and having the system synthesize these key materials, we can get arbitrarily strong.
Absolutely.
And the user doesn't have to worry about it, because all they're doing is they're logically thinking of it as an identity as a card, and they pick it, and all the magic happens underneath.
Now, I do see one subtle flaw.
Great. So
And-
we'd like to know that.
Cool, this
Well-
is news.
Well, and it's not, clearly it's not like an architectural flaw, system level
Yeah.
stuff, your certification. It's mainly, since you're not requiring a user to remember a password, and which is a great thing, it creates sort of problems when you have shared computers.
Right.
Right.
So my friend is using my session, goes to Amazon.com, InfoCard gets a list of my InfoCards, and will say, yeah.
Great point. Yeah, valid
Okay.
point. If you have a shared community of users sharing a computer, but not only a computer, but the same account,
Yeah.
right? Then yes, it is hard to distinguish between the set of cards that belong to one user versus another.
Certainly.
However, we do provide, just to accommodate those kind of cases, because often in the households, many family members actually share the same computer without creating different accounts.
Yep.
So we have this notion of PIN-protected cards to accommodate those situations. So in some sense, what that is a password to unlock the card for release, but it's not a password that I share with a site.
Absolutely.
Right, so I have a set of cards and Nigel has a set of cards, and they all reside on the same machine, in the same account. I can protect mine with my own pins, and he can protect his with his own pin. Now when the cards show up in an experience, I can only release my card because I must prove knowledge of a pin to my local system.
Fantastic.
So that's
That
how we
solves the
try to
problem.
that's how we try to address that.
Great.
Well, the other thing is you can have separate accounts, right? You have,
Well-
Yeah,
On the
That's
same
the best thing to do.
Yeah, that's
Yeah,
the best
that's the
thing.
best
Have
thing.
But it's
separate
not
accounts.
always the case.
right. So I'm just going to quickly, if you just show it again.
We are running low.
Right over time. Okay. All right.
But let's see this again.
I'm just going to I fix the network problem and well, is this on and off now? Sorry. it works
It's
so
funny
fast.
because Andy just showed it about 3
Sorry,
times in the background working.
It works so fast.
There we go.
Yeah, it works so fast, and then now I got problem again. Sorry.
It's okay.
Because of the network. Let me see. I like to show that you can crack open the token, and this is basically the code to crack open the token. And this is part of the WSCF, and just look at it, the token. So in this case is C identity something.
Are you showing the token at the bottom?
Yeah. I'm just going to go for now. And this is basically asking for some IDs, and that's the IDs.
So maybe Charles needs to focus on the window at the bottom. Is that what you were trying to show him? Or?
Oh no, here we go.
Okay.
Yes.
So there's a claim called private personal identifier.
And again, this is a FAT client, and we can look at the browser scenario, which we show in the BeautyS. Let's see. So I have a site. This is the simplest site.
Fabricom.
Fabricam.
Oh.
And if you look at the source code, it's very straightforward. It's very simple. And the logon page is actually just, let me make it bigger here. Well, it's good enough?
Yeah, that's fine.
Okay, just make it. So it's nothing more, it's just part of the forms here. So if you see here, there's an XHTML. So it is basically a binary behavior implementation
Mm-hmm.
in IE. So what you do there, if you look at it, it tells you, you can specify the issuer, the same thing that you specify at that config.
Mm-hmm.
You can also specify token type, in this case SAML 1.0 assertion.
Okay.
You can specify several claims, either optional or required claims.
Mm-hmm.
In this case, it's given name and surname. So that's all you need. Now, if I log on, if I click on this, it brings up the InfoCard. Same
Excellent.
thing. And you can just send it. And this will be post the token back to the some target URL. In this case, it's fabricam main.espx.
Okay.
It could be, it doesn't have to be ASP.NET. It could be some other, programming model,
Sure.
not ASP. So at that point, I just grab the token and I just display it in the base64 encoding.
Cool.
But again, same thing. I can crack open the token as well.
Excellent.
Okay.
Well, this is great stuff.
All right.
Thank you.
Great work, you guys.
Thanks.
Thank you for coming and
We'll
capturing.
definitely. We want to learn more as well. Thanks.